You know that device in your hand, the one you probably use 100 times a day? It feels so simple, right? So intuitive, almost like it's magic. But behind that smooth, glassy surface, there is an entire universe of hidden science. And today, we're going to peek under the hood. This quote just hits the nail on the head. A smartphone isn't just a single invention. Nope, it's more like they crammed centuries of human genius into a pocket-sized package. A whole library of scientific breakthroughs all firing off at the exact same time. So, to really get a handle on this, we're going to break it down. We're going to look at 4 huge fundamental challenges that scientists and engineers had to crack. You can think of them as the 4 giant pillars that are holding up the entire world of mobile technology. Okay, so here's our game plan. First, we're going to tackle the phone's brain, its intelligence. Then, we'll dive into how it actually works in the real world. After that, we'll see what it's made of, and finally, how it's designed just for us, for humans. It all comes together in what we're calling the symphony of science. First up, the intelligence challenge. I mean, before a phone can do anything at all, it needs a way to think, right? A way to process information. And the universal language for that kind of thinking? Well, it's math. Seriously, think about it. How does a little slab of glass and metal become smart? What gives it the power to calculate, to process, to actually understand what you want it to do? Well, the answer is in the pure, abstract world of mathematics. Math is basically the invisible architecture of your phone. It's the fundamental rulebook for everything, from the ridiculously precise layout of the circuits inside to the insane encryption that keeps your messages safe from prying eyes. And this is where it gets really, really cool. You see how these abstract ideas you might have learned in school connect to real stuff, you know? Number theory. Yeah, that's basically the bouncer for your banking app, keeping everything secure. And calculus. It's not just some boring class. It's what's happening in real time to create those buttery smooth 3D graphics in your favorite game. And get this, every single time you tap on an app, your phone is doing a quick little coordinate geometry problem. It's instantly finding the exact X and Y coordinates of your finger to know what you're asking it to do. That's high school math working at pretty much the speed of light. Okay, so let's move on to our second big challenge. Once you have the intelligence, the brain, you've got to make the thing actually do stuff in the physical world. And this is where physics steps onto the stage. So how does an idea, a bunch of ones and zeros, turn into a photograph or a phone call, or even just that little buzz in your pocket? Well, that's the functionality challenge. And its rulebook is written by the fundamental laws of the universe. Every single thing your phone does is just physics in action. You've got the flow of electrons giving it power, you've got electromagnetic waves flying through the air carrying your Wi-Fi signal, optics grabbing light for the camera, and acoustics turning vibrations in the air into a voice memo. It's all physics. The camera is just a perfect little example. It's this beautiful 4-step dance. Light from the world comes in, the lens bends it just right, it smacks into a sensor, and bam, that physical light energy is instantly converted into digital information. Pure physics. So we have a smart device that can actually function. Awesome. But what's it made of? That brings us to our third giant hurdle, the material challenge. And this is the domain of chemistry. You can't just build a tiny little supercomputer out of wood and stone. You need some seriously special stuff. Materials that are incredibly strong, but also lightweight. They have to be amazing at conducting electricity and somehow store a ton of energy in a teensy-weensy space. Just take the screen. We poke and swipe at it hundreds of times a day. It feels totally smooth, just like a regular piece of glass. But the reason it doesn't just explode into a million pieces the first time you drop it, well, that's a straight-up masterpiece of chemical engineering. So here's the secret sauce. Normal glass, mostly just silicon dioxide. But your phone screen is something called aluminosilicate glass. The best way to think about it is like reinforcing concrete with steel bars. Chemists have basically woven aluminum oxide into the very molecular structure of the glass, creating something that is incredibly tough and scratch-resistant. And chemistry is literally everywhere else in the phone. It's in the battery, with those lithium-ion reactions powering your whole day. It's in the crazy pure silicon that makes up the chips. It's in the powerful little magnets in your speakers, and even the plastic polymers that make up the case. All right, so we've built a smart, functional, and super durable device. We're done, right? Not quite. There's one final and maybe the most crucial piece of the puzzle, the human challenge. This is where biology steps in to connect all this amazing tech directly to us.
You can have the most brilliant piece of technology ever invented, but if it feels like holding a brick or the screen hurts your eyes to look at, it's a total failure. So how do you design it so it feels less like a tool and more like an extension of your own body?
This is where biology hands us the blueprint. The science of ergonomics, how our bodies work and move, tells designers exactly how to shape the phone so it fits perfectly in our hands. Vision science helps them calibrate the screen's color and brightness to perfectly match what our eyes are comfortable with. And then, of course, you've got biometrics. That fingerprint sensor isn't just a cool gadget. It's a direct application of biology. It's designed to understand the completely unique pattern of ridges on your skin to give you secure, instant access. It's technology literally built around you. So we've walked through these 4 massive challenges. But the real magic, the secret ingredient, is what happens when they all come together. The smartphone isn't a math project, or a physics project, or a chemistry project. No, it's a symphony, and all of them are playing together. And that is the big takeaway here. You have to have the math for the brains, the physics for the actions, the chemistry for the body, and the biology for the soul, for the human connection. If you take away any one of those pillars, the whole thing just collapses. It is the ultimate team-up. The smartphone is just this incredible testament to what we can achieve when different fields of science stop working in their own bubbles and start collaborating. And it just leaves you wondering, doesn't it? With all the knowledge we're gaining every single day, what amazing new symphony are we composing right now for the technologies of tomorrow?